So we have a horizontal bar. I'll show you a side view of this. So the side view is something like you have a cylinder. You have a horizontal track like this. Horizontal track like this. String wound on the cylinder. The string is being pulled here. So basically the string is being pulled like this with the force. The cylinder has radius of r and mass of r. And take just a minute. हाँ बता बता एक मिनट बता. So I can frame the question in many different ways. So let me frame all the questions. Question number one: if there is no slipping, find acceleration of the cylinder. Question number two: find F so that the cylinder just does not slip. इसका उल्टा क्वेश्चन हो सकता था, find the coefficient of friction. If the coefficient of friction here, the coefficient of friction here is given as mu. Right, so I could have said that find the coefficient of friction mu so that the cylinder does not slip. Both would be the same questions. I hope the question is clear to everyone. Horizontal tracks हैं, वो horizontal tracks में एक cylinder है and it is being pulled by a string as shown. उसको प्लैंक ले लो, प्लेटफॉर्म ले लो, जो भी लेना है उसको ले लो. It does not matter, right? They are horizontal strips of surface, and the cylinder is symmetrically placed, so you don't have to worry about N1, N2 is all same. नहीं शाना, यह शायद सही बोल रहा हूँ, मुझे याद नहीं है. नहीं गड़बड़ है शायद. ये क्या है भैया, एक्सलेशन निकाला है. सेकेंड पार्ट करो. ये क्या है प्रतीक्षा? हाँ ये सही लग रहा है. नहीं, पहले वाले आंसर में न्यू नहीं आ सकता है ना, बिकॉज पहले वाले आंसर में डज नॉट स्लिप. दूसरे वाले आंसर में आई टोल्ड यू लास्ट टाइम दैट न्यू हम तब लेके आएंगे पिक्चर में जब हमें फोर्स किया जाए. अगर हमें मालूम है स्लिपिंग नहीं हो रही है, वी विल अज्यूम दैट फ्रिक्शन इज लेस देन द मैक्सिमम. नहीं करो, गलत आंसर. अच्छा क्वेश्चन टू, नहीं नहीं नहीं.
अगर नो स्लिपिंग के केस में भी फ्रिक्शन तो रहेगा ना।
हाँ, स्प्रिंग वाले केस में फ्रिक्शन मैक्स हो जाएगा ना। हाँ, सही है। So for question 1, all you have to do is draw the correct FBT. F and G and F. Now you notice that this question is exactly the same as मैं यहाँ पे ऐसे पुल कर, that is the whole point. आप सिलेंडर को नीचे पुल कर रहे हो, ठीक है ना? इक्वेशन थोड़े से चेंज हो जाएंगे, but this is almost equivalent to this. So the equations will be F is equal to MA and FR minus FR is equal to MR square by 2 into alpha. And from the constraints, you are going to get A is equal to R alpha. So this alpha you can write as A by 2. So very simple equation emerges. F minus F is equal to MA by 2. Add them up and you get F is equal to 3MA by 2. And therefore A is equal to 2F by 3M. Right?
So वो जो पहली क्वेश्चन है वो 2f equal to ma क्यों नहीं?
हाँ?
2f equal to ma क्यों नहीं?
2F equal to हाँ मैटर अच्छा मैं समझ गया ओके so the question is very good question. Yes. So the question is that if there is a friction force here and there is a friction force here, why have I not taken it as 2F? Well, the answer is that I have considered the net friction force. Okay? I have considered the net friction force. If you want to consider separately, you can. In that case, 2F will be equal to 2MA and FR minus 2FR will be MR square by 2 alpha. And it will make absolutely no difference to the answer. I told you that the cylinder is symmetrical and the force is being applied from the middle. Everything is symmetrical in the problem. अगर asymmetrical होता तो बड़ी प्रॉब्लम हो जाती. यहाँ पे जो नॉर्मल रिएक्शन है वो भी सेम है और जो फ्रिक्शन है वो भी सेम. So you can either take the total normal reaction as n, you can take this as net normal reaction, or you can take the factor of 2. It will make absolutely no change in the final, make no difference in the final answer. The second part करो. हाँ, very good Tarun, yes. हो गए बाकी लोग इतना इतना डिफिकल्ट थोड़ी ना है. I mean, of course difficult है. I'm not saying difficult नहीं है, but it should not be difficult for you because once you get the hang of it, it is the same thing which is repeating again and again. So इसमें क्या हो जाएगा? The equations will remain the same, except for the fact that now friction will be maximum. So mu n is equal to A, पहला equation, and F R minus mu n R is equal to m A by 2. So this tells me that F, यहाँ पे R भी कट गया. This tells me that F minus mu n is equal to mu n by 2. So F should be equal to 3 by 2 mu n. All that remains is that I have to find n. So if you look at the FBT, you will get F plus mg is equal to n. So 2f is equal to 3 mu into f plus mg. So 2f is equal to 3 mu f plus 3 mg, 3 mu mg. This means that 2 minus 3 mu f is equal to 3 mu mg. So f must be equal to 3 mu mg on 2 minus 3 mu. Right? Of course, this sort of opens us up to many.
सर फर्स्ट रिजल्ट में
हाँ.
सर फर्स्ट रिजल्ट तो हम सीधा ए की वैल्यू पुट करके भी ला सकते हैं.
फर्स्ट रिजल्ट मतलब
सर f इक्वल टू 3/2 म्यू n.
इसकी वैल्यू कहाँ पुट करके ले आओ?
सर पिछले क्वेश्चन में जो एक्सेलरेशन निकाला था ये 2f/3 हम इधर डाल. सर तो इससे भी तो वही आ जाएगा ना वो पहला रिजल्ट.
इससे?
हाँ सर.
इससे क्या आ जाएगा मुझे समझ में नहीं आ रहा.
सर f इक्वल टू ma डाल दीजिए ना, खाली फ्रिक्शनल फोर्स इक्वल टू ma. मतलब a का वैल्यू सब्स्टिट्यूट कर दीजिए ना उसमें.
तो हमें a थोड़ा ना निकालना है, हमें तो.
बट सर
बट एक ही
2f
एक्सप्रेशन
सर ए की वैल्यू हमारे पास ऑलरेडी है, हम डायरेक्ट डाल देंगे तो एफ का सीधे एक्सप्रेशन आ जाएगा.
हाँ ठीक है, यहाँ पे यू वांट टू पुट द वैल्यू ऑफ a ना.
हाँ सर.
हाँ बिल्कुल बिल्कुल आएगा, क्यों नहीं आएगा. Well, I just wanted to solve everything from the beginning, so that's why. So next question. So we have, well, it's not exactly a pulley. So it's something like this. Looks like rolling pin. And this rolling pin is hanging by a thread here. And there is a block of mass. Let me show you the side view. Maybe that will be more. This is the big cylinder. This is the small cylinder. And we have a string attached like so. And we have mass attached like so. Okay. Now, what are the things which are given? इसका रेडियस r है, इसका रेडियस 2r है, इसका मास m है, मोमेंट ऑफ इनर्शिया I है, इसका मास m. I hope the question is clear. Find the acceleration of small m. No slipping, of course. Find the acceleration of small. And the moment of inertia is given about the center of mass analysis. हाँ, शौनक ये इसको ये नहीं बोलेंगे that these two cylinders are attached. We will say that this is a complete rigid body. इसका moment of inertia I मैंने आपको दिया हुआ. Moment of inertia of the object is given. तो अब जब moment of inertia ही given है तो फिर उसका जो content है, I don't think उसका कोई use है, except for the fact कि उसका radius r है और 2r है. सिलेंडर है क्या है उससे हमें मतलब नहीं होना चाहिए. मोमेंट ऑफ इनर्शिया इज गिवन एज नहीं लो है सॉलिड है उससे कोई लेना देना ही नहीं है बिकॉज हमें मोमेंट ऑफ इनर्शिया मालूम. जल्दी जल्दी करो भाई, 1 घंटे में 10 क्वेश्चन तो होना चाहिए। हाँ, एक नहीं, गलत आंसर। नहीं यार, ये गलत आंसर है, सबका सेम आंसर गलत क्यों आ रहा है? जैसा मैंने बोला है वैसे करना है। पहला, इस ऑब्जेक्ट का कैसा मोशन हो रहा है ये हमें रियलाइज करना है। We can safely say that the block is undergoing translation. We can also say that the object of moment of inertia I is going rotation plus translation. इसका मतलब कि हमारे पास 3 फ्री बॉडी डायग्राम और 3 इक्वेशन यहाँ से आनी चाहिए, और चौथी इक्वेशन हमारे पास कंस्ट्रेंट से आनी चाहिए। 4 equations, 4 unknowns should present themselves to you.
सर वो मोमेंट ऑफ इनर्शिया आई वाला ऑब्जेक्ट तो स्ट्रिंग से टाइड है ना, सीलिंग से, तो वो ओनली रोटेशनल होगा ना?
नहीं भाई, तो ध्यान से देखो, अनवाइंड होएगा ना स्ट्रिंग, उस पर ही नहीं होएगा। वाह,
सर इस वाले में जो T1 और T2 लेंगे अलग अलग, उसमें रिलेशन बना सकते हैं क्या, या अलग अलग ही होंगे?
नहीं, अलग अलग रहेंगे, उसमें उसमें कोई रिलेशन नहीं आने वाला। हाउ कैन यू गेट अ रिलेशनशिप बिटवीन?
सर आपको भेजा।
अरे 3 का फैक्टर गड़बड़ लग रहा है बात। एक 3 का फैक्टर कहीं गायब है, बाकी सब सही है। ध्यान से देख।
ओके ओके सर, चेक करता हूँ।
एक 3 का फैक्टर गड़बड़।
सर स्मॉल m का कोएफिशिएंट नीचे कैपिटल 3 मतलब 3।
लिख के भेज। नहीं, फिर भी 3 का फैक्टर। ये मैं I'll rub this out so I can do the work here. Rub this diagram out. Okay, and again, please notice you don't have to take 2t, just one tension will suffice because everything is symmetrical, so there is no difference. So let's say that the tension here is T1. Let's say that the tension here is T2. So obviously the tension here is also T2. And then we will write for the translation of M.
सर ग्राउंड फ्रेम में लाना भूल गया था उसे। आ गया सर फैक्टर।
किस फ्रेम में पता नहीं चल रहा है, ग्राउंड फ्रेम में काम कर रहा है। ठीक है। For translation of M, we get mg minus T2 is equal to ma2. So I'm assuming that this guy has an acceleration of it. Therefore, I will assume that the center of mass has an acceleration a1 downward for the object. इसके लिए क्या equation लिखेंगे? So for the translation of capital M, you are going to get mg plus T2 minus T1 is equal to ma1. And now comes the two most important. See, यहाँ तक आपको मालूम है, you know this. यहाँ तक किसी को प्रॉब्लम नहीं होना चाहिए। अब आगे देखो. For rotation of M, can you tell me the equation? शौनक बता सकता है equation के लिए, rotation के लिए क्या equation लिखा? शौनक कहाँ गायब हो गया है? रोटेशन के लिए क्या इक्वेशन लिखूं मैं?
U1R plus T2 into 2R equals yeah.
सर T1R plus T2 T2R equal to I alpha और माइनस आएगा T1 T2 के बीच में।
क्यों फंस रहा है यार, मुझे समझ में नहीं आ रहा।
सर प्लस ही रहेगा, दोनों का सेम ही
सर सेम सेंस है ना,
सेम ही
rotation का।
रोटेशन।
प्लस आएगा। माइनस क्यों दिख रहा है?
अरे सॉरी हाँ।
I hope everybody got this equation. I mean, this, if you have got this equation, then you have done 75% of the work. And for the remainder 25, constraints. Please follow me very, very carefully. Since the center of mass of this object of mass m is moving downward with an acceleration of a1. This means that this point must also be moving with an acceleration of a1. And since due to rotation, which is clockwise alpha, this point must be moving down with an acceleration of r alpha. Therefore, the net acceleration downwards of this point must be a1 plus r alpha. And the net acceleration down of this point must be the same as the net acceleration of this point. So the constraint equation that I get is a1 plus r alpha is equal to a. But there is a snag. मुझसे थोड़ी गड़बड़ हो गई थी. 4 equation 4 unknown नहीं आना चाहिए. 5 equation 5 unknown आना चाहिए. क्यों? Let's see. a1 a2 alpha 3 ये unknown हो गए. t1 t2 5 unknown हो गए टोटल. 4 इक्वेशन हमने ऑलरेडी लिख दिया है. एक कंस्ट्रेंट का इक्वेशन और आना चाहिए. और चूंकि ये हमें दिखाई दे रहा है कि स्ट्रिंग वाला मामला है, स्ट्रिंग कंस्ट्रेंट ही होना चाहिए. I notice that this point, the one that I've just marked with yellow, has 0 acceleration. And this must be the same as acceleration of this point.
सर
which will
r alpha की जगह 2r alpha होना चाहिए ना?
be 2r alpha, suppose. So this point has an acceleration of a1 due to translation, and it has an acceleration of r alpha due to rotation. So the net acceleration of this point is a minus r alpha, but it must be equal to 0. Second is that a1 minus r alpha is equal to 0. Okay, so now I think that things are pretty much wrapped up. This tells me that a1 is equal to r alpha, and if this is the case, I get a2 is equal to 3r alpha. Okay, so let's write these equations again. mg minus t2 is equal to m into a2, right? I want to find a2. उसके बाद से I have mg plus t2 minus t1 is equal to capital M a1, but I don't want to write a1, I want to write a2, and from here I see that also we have a2 is equal to 3a1. Right? So I will write here a2 upon 3. And then the third equation, I will write 2t2 plus t1 is equal to I divided by r into alpha. But I want alpha in terms of, remember, a2. So I will write here a2 by 3r. That will become 3h. Now all I need to do is add. Okay. All I need to do is add, but before I add, I must multiply the topmost equation with 3, because if I multiply by 3, then t2 will cancel out. So in the left hand side, 3t2, 2t2, t2 cancels out, minus t1 plus t1 cancels out, and I get 3mg plus mg, okay, is equal to 3m plus m by 3 plus I by 3r square a2. So this tells me that a2, which is what we want to which is what we want to work out, will be equal to 3G 3m plus m divided by m plus 9m plus I by r square. Right? यही आंसर आया ना पार्थ फाइनली?
हाँ सर, वो ग्राउंड फ्रेम में आने के बाद वही होगा।
फ्रेम चेंज करना should only be done in extreme circumstances. फ्रेम चेंज में बहुत कंफ्यूजन क्रिएट हो सकता है।
सर
हाँ
सर वो कंस्ट्रेंट का एक बार बताएंगे, एक बार इक्वेशन फिर से।
कौन सा, पहला वाला कि दूसरा वाला?
पहला वाला।
देखो भाई सब लोग ध्यान से देखो। I will change the slide, so please take a screenshot if you want. I am going to explain the second constraint equation.
सर छोटे वाले सर्कल और बड़े वाले सर्कल का अल्फा सेम क्यों?
हाँ सब एक्सप्लेन, शॉट ले लो। So the diagram given to us is something like this, right? Now, if we have an object which is connected by a string, this guy, right? इसका मैं side view भी बना दे रहा हूँ यहाँ पे। Okay, so this is 2r, and we have already seen that the acceleration of center of mass is a1 and the rotation about center of mass is alpha. Right, so this point is with an acceleration of a1 and rotating with an angular acceleration of alpha. Okay, now what is the theorem that I told you? The theorem का नाम कभी बताता नहीं हूँ क्योंकि I don't know how to Google में देखा जा सकता है, pronounce कैसे करते हैं मुझे नहीं मालूम. You can choose your own pronunciation. So this theorem says that the motion of a rigid body is equal to the motion of center of mass plus the motion about center of mass. This was very big thing. This is very hard to digest, but this is how it works. So what this tells me is that if you have an object which is rotating and translating, then it is it is guaranteed that any point on the rigid body will have two types of acceleration, if I can use the word types. One will be the acceleration due to translation, the other will be acceleration due to rotation. Acceleration due to translation must be the same as the acceleration of the center of mass. Therefore, this point must have an acceleration a1 because this is the acceleration due to translation. And since the center of mass is moving with a1 downwards, the rim point of this object must also be moving with an acceleration a1 downwards. it must also have an acceleration of r alpha, that is distance from the origin, distance from the axis into alpha, right? And since alpha we have chosen as clockwise, therefore this must be the direction and value of r alpha. So the net downward acceleration of this point is a1 plus 2r alpha. So this point will have an acceleration a1, also have an acceleration of 2r alpha. Therefore, the net acceleration of this point will be a1 plus 2r alpha. And this must be the same as the acceleration of this point, because these two points are connected by a string. Their acceleration along the string must be same. And this is a2. We have assumed that this object is going down with a2. So we must get a2 is equal to a1 plus 2r. आया समझ में भी?
Yes, sir.
It's pronounced as इंटरनेट पे चले यार, इंटरनेट पे जाना तो बाद में जाना ना, क्लास को जाना तो। ओके चलो नेक्स्ट क्वेश्चन। Please take a screenshot if you want. I'll move on to the next question. All right. So the next question is, okay, so this is not a cylinder, but this is a spool. अगर आपने स्पूल नहीं देखा हो तो if you remember जहाँ पे स्विंग के लिए स्ट्रिंग स्टोर किया जाता है इस ऑब्जेक्ट पे, वो एक स्पूल होता है. Spool is nothing but a cylinder which has two discs of a greater radii stuck on both ends. So we have so the question is, a spool with a thread wound on it is placed on an inclined smooth plane set at an angle of theta. The free end of the thread is attached to the wall The mass of the spool is m. The moment of inertia about its axis passing through center of mass is I. And the radius of the wound thread layer is r. Find the acceleration of the spool. Find the acceleration of the spool. वो गिवन नहीं. स्पूल के बड़े डिस्क का रेडियस क्या है? दैट इज नॉट गिवन. Surface is smooth. Very weird. Surface is smooth.
सर 4 इक्वेशंस आएंगे ना?
तीन आने चाहिए मेरे ख्याल से. चार आ रही है.
सर 3 ही आ रही हैं.
तीन ही आने चाहिए. हाँ सही.
सर वो गलती से h एक्स्ट्रा चला गया.
हाँ नहीं
तो
समझ
H-
गया. अच्छे कोई मतलब. क्या हुए बाकी लोग? कहाँ चले? क्या हो गया है? टफ नहीं है भाई. देखो एम जी साइन थीटा माइनस टी इज इक्वल टू एम. राइट, ये तो स्टैंडर्ड हो गया ना भाई, इसमें कोई इशू ही नहीं है. आर इज इक्वल टू आई अल्फा, इसमें भी कोई प्रॉब्लम नहीं होनी चाहिए. वेरी गुड. यस वेरी. उसके बाद से ये पॉइंट और ये पॉइंट they should have the same acceleration because they are connected to each other by a string. हाँ बिल्कुल. तो ये पॉइंट अगर ये एक्सेलरेशन से नीचे जा रहा है और अगर इसके ऊपर टॉर्क वेरी गुड करोगे अल्फा ऐसे है, so this blue point must have an acceleration a like this, must have an acceleration r alpha like this. From the constraints we get a is equal to r alpha. Okay. Acceleration should be equal to mg sin theta divided by m plus I by r square, right? Very good. Yes. ठीक है? Okay. चल नेक्स्ट, थोड़ा सा ध्यान से करना है प्लीज. Ring of mass m plus r as a point particle of mass m stuck in its rim as shown. OP is horizontal and object is released. Find initial acceleration if surface is sufficiently rough to prevent slipping. नहीं नहीं तो नहीं बात नहीं धीरे धीरे करो भाई नहीं समझ okay चलो देखो so this is the first time that I am actually I don't know whether you realize this or not but this is the first time that I gave you a question where you will find the torque about a point which is not the center of mass. So in this case, the center of mass of the object will lie somewhere along the line of B. But I will take the origin, I will take the point about which I want to find the torque as O. Now, when drawing the rotational free body diagram, there are two choices. Choice 1, choice 2. अभी मैं ओरिजिन लेने की कोई बात नहीं कर रहा हूँ अभी मैं केवल रोटेशनल फ्री बॉडी डायग्राम. So you can either say that look the gravitational force is acting from here and it is acting from here and there is a normal force here and there is a friction force. Okay, nahi bhaiya. You can either say this or choice 2 you can say that a force of m plus mg is acting from this point and this point is at a distance of either याद है ना कैसे करते थे दूसरा मास total distance divided by m plus m or capital M r divided by m. You can either say that the gravitational force is acting from the center of mass or you can say individually कि नहीं भाई देखो रिंग के लिए रिंग से सेंटर ऑफ मास से फोर्स लगी है और जो पॉइंट पार्टिकल है उसके ऊपर पॉइंट पार्टिकल के लोकेशन पे ग्रेविटेशनल फोर्स. Either choose you can choose either of these two things as far as mg is concerned. Okay? As far as mg is concerned. Okay. I'm going to change the slide. Please take a screenshot. I'm going to change the slide. Please take a screenshot. Now, you will get the same answer that I am going to get if you were to take your origin of torque as the center of mass of the object or the center of the ring. There is a very special reason for that, which we will discuss eventually. But if you are faced with of course, I will give you a list of checks. क्या checks carry out करने चाहिए origin choose करने से पहले, but I don't want to add to your burdens right now. So I will just, for the sake of simplicity and continuity, I will take the center of the ring as the origin. Right? So what are the torques acting on it? And I will choose choice 1. I will choose this as my FBD. I'm taking this as the center. I hope you can see why I'm taking this as the origin, because the torque due to N and capital Mg will go away. So I will get the equation as mgr minus fr is equal to I alpha. Also, please notice that x-axis, okay, along the x-axis, there is only one force, that is friction. This object को जो आगे करेगा, that will be friction. बाकी सारी forces vertical हैं. So the second equation that I get is that F is equal to m plus m into A. So mgr minus fr is equal to m plus, sorry, is equal to capital mr square, which is the moment of inertia of the ring, plus mr square, which is the moment of inertia of the point particle with respect to the origin that I have chosen. And constraint will again tell me constraint वाला कौन बताएगा? Constraint वाला who will tell? Anybody?
सर सेम ही रहेगा ना, A is equal to R alpha.
So I will get, yes. So I will get mg minus f equal to m plus m into A. F is equal to m plus m. So A will be equal to mg upon 2. ये पार्ट का सही बता रहे सर.
हाँ सर, मैंने यही बताया था.
सही. ठीक है. Okay. So I will stop here. In the next class, we will discuss some kinematics of rotation, and then we'll move on to work energy theorem in rotation. Once I have finished work energy theorem, then we'll move on to collisions, angular momentum and collisions. Once I've finished angular momentum and collisions, then we'll come back to this question and we'll discuss where else to take the origin and what kind of effects will it have. Okay. So अभी भी we are very we have had a very patchy sort of coverage of this chapter. So as far as what I have taught, if you get a question where equilibrium is involved, or if you get a question where dynamics is involved, that means that they are asking you for acceleration or they are asking you for forces, you should be able to do all the questions. But the questions where there is collision going on, the questions where they are asking for the velocity of the object, वहाँ पे अभी आप नहीं कर पाओगे. So we'll come to that. So now the part will be very rapid. This was the. So we'll revisit this question at the end of the chapter, and I will discuss what happens when you start choosing points which are not the center of mass as the origin. Okay, sure. So I'll leave you. We'll meet in the next class.